What is computational thinking? Computational thinking is not thinking like a computer or a computer scientist. It is in fact something that people do, and it includes the ability to think logically, algorithmically, recursively, and abstractly. Barefoot 2014 states, computational thinking is learning to think in ways which allows us to solve more problems more effectively, and when appropriate use computers to help us do so. According to the national curriculum, a high-quality computing education equips pupils to use computational thinking and creativity to understand and change the world. Decomposition involves breaking down a larger problem into smaller parts, which are easier to tackle. Not only do you see this in the computing curriculum, for example, when children are creating a game on Scratch, they might write a separate code for the character's sound, and then write a separate code for the character's movement. We also see this in the maths curriculum. For example, when children are working through a word problem, they will often break down the problem into different parts. Therefore, decomposition is already in the maths curriculum, although not stated, as children are breaking down problems to solve the problem. Berry 2014 states algorithms are step-by-step instructions to get something done, or a set of rules describing how something works. We see this in computing when children are programming B-bots. Children will have to provide the B-bot with step-by-step instructions to reach a certain destination using a certain path. We also see algorithms in the primary national curriculum for English, where children are writing step-by-step instructions. So many computational thinking aspects are embedded into literacy, maths and reading. According to Barnes Stephenson, some teachers are finding it difficult to embed computational thinking into their lessons, as teachers have limited understanding, knowledge and skills of how to embed computational thinking into their lessons. It is therefore important teachers have a sound understanding of computational thinking and how it can be embedded into these subjects. This can be done through Google and Barefoot, who offer computational thinking courses to help teachers understand what it is and how it can be implemented into lessons to help children learn. What would computational thinking look like in practice? In literacy, computational thinking can be added through the use of Scratch. For example, children can create animations of different versions of a story that they are studying in class. When creating the story, children will be using computational thinking aspects such as decomposition, abstraction, problem solving, and algorithms. Children will have to decompose the story into beginning, middle, and end, and think about what happens in each section. They would also have to think about the different characters and aspects of the story they would like to include. During my block school experience, Scratch was used by pupils in Year 3 to create mini games and quizzes for maths. This was used as a starter activity. This ties into Piaget's theory of constructivism, as children are actively learning to create meaning, therefore promotes learning. Kava and Resnick 2011 states knowledge is actively constructed by the mind of the learner. Children don't get ideas, they make ideas. During my block school experience, teachers would also embed computational thinking aspects through the use of beatbots in maths. Pupils would program the beatbot to follow a line and predict and measure how far the beatbot travelled. In conclusion, I believe computational thinking can offer a range of skills that will help children, such as effectively problem solving. However, the lack of subject knowledge and skills some teachers have of what computational thinking is and how to embed it into lessons makes it difficult for some teachers to do this. Therefore, for my future practice, I will try to implement a range of lessons which embed aspects of computational thinking, as computational thinking is a fundamental skill for everyone, not just for computer scientists.